Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to bring you another episode in our continuing series about the constellations. Last time we completed the 3 constellations that make up the Summer Triangle. This time we're going to look at another summer constellation. During the high summer, this constellation will be very low in the south. Find south by putting the North Star Polaris to your back, and then look towards the horizon. There you will find a distinct line of stars that curves, resembling a hook with a handle on its end. This is the constellation Scorpius, the Scorpion. That curved-shaped handle marks the head and claws of the scorpion. The body continues down that line until the tail hooks up over the back, producing a stinger. Scorpius is a major and distinctive constellation of the summer, but because it's close to the horizon, it's only visible to Michigan in the high summer months. The brightest star in Scorpius is a bright red-orange star named Antares. The name Antares can be broken down into the parts Ant and Ares, which means the rival of Ares. Ares is the Greek name for the god of war. In Latin, the god of war is named Mars, so Antares is the rival of Mars in the night sky. It's called this because Antares is about the same color and brightness one can usually expect to see from the planet Mars. And the Martian orbit passes very close to Antares as seen from Earth. So over the years, Mars passes by Antares in the sky. When this happens, it's easy to confuse the two. Antares is a larger star than the Sun, with about 12 times the Sun's mass, and given the color of the star, we can tell that Antares is nearing the end of its life. Gravity is the force that pulls things together, and the strength of gravity is proportional to the mass of an object. Stars are huge, they're made of lots of stuff, and that mass is pulling all other mass down to the center of the star. This creates enormous pressures in the core of the star, pressures so great that the very atoms of the star are forced together. Stars are almost entirely composed of hydrogen atoms, and when these hydrogen atoms are forced together with enough energy that they can stick together or fuse, they produce helium atoms. This is how atoms are created. They are built in the cores of stars. When this fusion process takes place, a significant amount of energy is released in the form of electromagnetic radiation. Stars are huge though, so this process isn't happening once. It's happening trillions and trillions and trillions of times every second. All of this energy pushes back on the infalling mass, and the star reaches a balance between gravity pulling in and radiation pushing out. It can take billions of years, but eventually a star will run out of hydrogen atoms to fuse. If the star is big enough, if there is enough gravity to cause the core pressure to increase to the point where helium atoms can be pushed together, then helium can be fused into carbon, and carbon into oxygen, and so on up the periodic table of elements. Each successive element requires more pressure, but liberates less energy, but it's still enough to keep this balance. That is, until the star starts to produce iron. Iron atoms don't liberate enough energy to balance against the crushing pressures due to gravity. As soon as iron is produced, the star is lost. The core of the star quickly collapses in on itself until other natural forces halt its motion. The upper layers of the star fall in and impact on the collapsed core of the star. These outer layers rebound off the ultra-dense stellar core and are ejected at tremendous velocity. This is a supernova, and supernovae are the ends of large stars. Antares will someday explode as a supernova, maybe sometime in the next 10,000 years. Antares is far enough away that it doesn't present a threat to life on Earth. But when it explodes, it will rival the brightness of the full moon. That peak brightness will last for about 2 weeks, and it will still be very bright for about 100 days. But then the supernova will slowly fade over the next couple of years. So if it's clear where you are tonight, go out and look for Scorpius low on the southern horizon, and that bright star Antares, and try to imagine what it will look like on that night in the not too distant future, when that star suddenly becomes the brightest thing in the night sky. That's it for today. Next time we'll continue looking at the summer constellations. This is Brian from the Delta College Planetarium, wishing you clear skies.